Good morning, everyone. Welcome to the Reinventing Your Product Design Process session. I'm Patrick O'Brien. I'm going to turn it over to Tobias to kick off the presentation.
Thank you very much, Pat. So this is starting off reinventing product design. And the challenges for companies today of launching products faster while lowering costs, doing more with less, along with the erosion of manufacturing process knowledge in today's workforce, are more apparent than ever. And they do have significant impact on a company's performance and effectivity. Time and capacity are tied up by late-stage ECOs causing churn. Product launch dates are at risk and or sometimes late, and products don't release at target cost or do hit their margin. They might miss their projected margin goals. This impacts to the business, increases the need to provide engineering teams with visibility and automated early warnings of cost and manufacturability issues as they continue to develop new products. It is key to improve engineering efficiency to enable the right people to take the right decisions at the right time, along with your product development process. And if we look at this in a more graphical way, we can see on the x-axis the product development process timeline, and on the y-axis we can see the completeness of our new product initiative. The graph that we see now in between is the digital twin, a digital representation of the design and the processes to manufacture this product. It matures up to the peak, up to design freeze, and then sometimes not everything goes quite ideal, and there are some bumps, there's some churn, there's some changes in the design, in the manufacturing processes. There are some areas that we need to fine-tune a bit. So those iterations towards the end, they take resource and efforts. The goal would be to do those iterations virtually alongside the design process to avoid late-stage churn. Taking away those late-stage iterations provides us now with two options. So we can pull in the release date to get to market earlier, shorten our product development cycle, and win more business. For some companies, that might not work and they're constrained or the date is fixed in time. So here we can shift the curve to the right a bit and use the freed up resources toward the end of the process and invest them early on to increase innovation. Innovation focused on our product initiative, as well as being more innovative on how we approach manufacturing and the sourcing strategy of our product. And then there's another element where we can do more with the same people. So we can use the resources that we freed up involved in late stage churn and already focus them on our next project, which increases engineering efficiency. So we can do more with less, but how can we actually accomplish this without unloading more work on the engineer's desk that is already busy today? That is something that we see in a minute. First of all, we have to take one step back and go back to overlay what is our window of opportunity here. So if you look at the yellow graph now compared to the digital twin is our ability to influence decisions, influence cost and manufacturability. So on the left area, when we start the development process, we have very high ability to impact cost and manufacturability, but we have a very early stage of our digital twin of our product definition. And then that flips as closer we come to the release date, where we have a full detailed product, a fully defined digital twin, but we have less ability to impact, influence, cost and manufacturability. So the window of opportunity that we have here is when we do the CAD design. So from the first CAD model to final design freeze, where we actually do the detailed design and develop our product and the digital twin to have the right insights in terms of cost and manufacturability as we do this. And in this window, aPriori can bring value with the insights we provide into manufacturability and cost to support decisions. And that brings us back to the point I was making a second too early. How do we do this now to get this on engineers' desk that have already a pretty high workload? How we do this is with our new product Cost Insight Generate that helps us with democratizing cost and manufacturing expert know-how across engineering communities to empower and support decision making. So we apply disruptive technology without disrupting the engineer in its workflow today, accompanied by another aspect of aPriori's product portfolio, which is designed to cost and designed to manufacturability information that we add to the digital twin to enable in-depth and detailed analysis and insights when needed to develop better products faster. At this point, I'm happy to step back and hand it back to Pat, who will share the details on Cost Insight Generate with us.
Thanks, Tobias. And if I knew how to put my video back on, I would. But without that, let me start continuing. So I did promise a confession. It was about a year ago when, well over a year ago, the last Cost Insight user conference, when I first introduced this new product. And we talked about integrating with PLM systems, automating analysis of CAD models, pushing out insights to key stakeholders. And we called this thing EV-DFMC, which was early visibility for for manufacturing, design and manufacturing guidance, and also cost information. So I guess my video's there. Thank you. There we go. Sorry about that. Anyways, that was a mouthful, and we had a lot of trouble with it. And I told you at the conference last year that we had this brand new name. It was called Run DMC, and I was really excited about that. We spent a lot of money in the marketing department branding that. And at the last minute, we found out from the lawyers that we weren't allowed to use that name. Apparently, some obscure hip hop group in the 80s had stolen and trademarked the name. So we've got a new name, Cost Insight Generate, and I think it's a great name. And thanks to the marketing guys for coming up with that. And very excited to give you an update. We've made a lot of progress since we talked last year. We have customers who are beginning, along with our services organizations, to roll this out. I hope you got to see Sam Kroger's presentation earlier this morning, which talked about his experience as an AGCO, and they're deploying Cost Insight Generate. So if you didn't see that, go back and watch that video. So there's some key principles that Cost Insight Generate, think of them as aPriori principles. So we're extending our product line along enhancing our DFM and cost insights guidance. We're looking at provide secure collaboration. We're also looking at extending automation and integration, and Cost Insight Generate plays a big role in each of these. So let's look at the first one, insights and the drivers of product costs. So manufacturability guidance. Stan sort of talked about this as, design issues and outliers and things that don't cost, and providing that information early in the design cycle to design engineers is invaluable in helping them understand what things are driving costs and avoiding that cost down the road. And manufacturing details. So think of the things like the routings and the machines that are being used, the cycle times on those machines, setup costs, and all of this is valuable information to give to the manufacturing side so that they can understand some of the drivers as well, and look at how they can achieve some trade-offs and decisions early in the design cycle. And then finally, the sort of cost breakdown, detailed cost breakdown around material cost, labor cost, overheads, etc. And that's really valuable information for sourcing procurement people when they're supporting fact-based negotiations with their suppliers. So Mark Dignan is going to, after me, talk a lot about what are improvements in this area, but this is really the insights that we're trying to automate and get into the hands of key stakeholders. Now, Stan talked about this workflow. Let me just, for people who haven't seen this before, this is sort of a simple kind of workflow that illustrates some of what Cost Insight Generate can do, but it's not the only thing. I'll talk about some other example workflows as well as we go through this, but a design engineer is working in their CAD environment, iterating over designs, checking them into a PLM system. Then aPriori CI Generate solution is integrated with that PLM system. So there's multiple ways this could work. One would be checking periodically, like daily, for any parts that are checked in and meet other criteria. For example, what commodity you're using for that. Is it a part that should be costed, etc.? So we pull the parts that should be costed. We cost those through our process, and we'll look at that in a minute. And then we are able to push back results. So looking at the part object in the PLM system, we can update maybe a cost information, a risk rating. We can generate a report, attach that to the PLM system as well. The other kind of thing we can do is send out an email notification, and that could be to the design engineer. It could be to multiple people, depending on what you want to do at this point. Typically, that's going to give them a summary of the parts that were costed and things that they should be interested in. And then you can look at fields like the risk rating, cost information, the cost status itself, whether it passed or failed, etc. Along with this comes links to those parts. Design engineer then can click on that link in the email, for example, or in the part report, go into CI design, and using the DFM viewer there, look at the guidance, look at cost information, and take action on that. So that's a typical kind of workflow. Just a quick overview of what the Cost Insight Generate product really is. So it's new, the solution itself, but it's leveraging a lot of the key capabilities in the whole aPriori product line. So the costing engine itself and the analysis it's using for CAD geometry and PMI attribute stuff, cost models, over 270 of those, leveraging the regional data libraries, 80 or so of those, the guidance information, the interactive reporting, cost insight, all of these things are coming together. And what's new are really three things. First, that system integration into your enterprise applications of supporting the engineering organization. So connecting directly into those systems. Second is the automated analysis, being able to set up workflows that grab the parts that you need on a cycle, a periodic cycle. Maybe it's daily, maybe it's hourly, depending on your use case, and then automatically analyzing those parts and generating the insights. And taking those insights and pushing them out to the people, the key stakeholders that need to see that, whether that's a design engineer, a cost engineer, project leads, etc., and updating other systems like PLM systems with that information. So just a quick overview of the products and the solution in general. So starting on the top side, left-hand side at the top, the aPriori agent is a piece of code that really is the glue between the back-end systems like your PLM system and the CI Connect application. So it's going to execute queries on the PLM system to find the part objects and pull the CAD files over so that aPriori or CI Connect can cost those. It's also going to take results that come back from the results of the costing and the insights and push those back to the PLM system. CI Connect is a new application, and this is designed for project leads, deployment leads, etc., to set up. Really, you're looking at 2 or 3 things there that you want to do. The first is setting up the mapping between the agent and the PLM system. So which fields can query, what is the part object that you're using. We support Team Center and Windchill. They have different part objects that you can query against. How do you find other information like the check-in user and things that it needs to understand from the PLM system to do the notification, to update the parts correctly. Then you're going to set up workflows, and that's the what we just showed. So what is the sequence of events? And I'll talk a little bit more about that. The third thing in CI Connect, you come back and you can check the results of the workflows. When the workflow actually runs, we call that a job. And then that job gets recorded in the system, the results of the parts. You can go in and look and make sure that the workflow is working as expected and the results are coming back as expected as well. CI Connect then uses these underlying services, and all of this is in the cloud here. The reporting service, the insight service that's generating all of the results, and notification service for emails. And then it's also working in collaboration with other products. So CI Design, CI Report, aPRO are there as well. And you can use those tools then as CI Connect is generating the costings to go in and view results. So CI Report, you can use DC reports, et cetera, and things like that. CI Design, click directly in and go in and work on parts. And aPriori can also look at the same parts that are getting costed through this automated platform. In terms of just how this is set up, everything is in the cloud that you see in this box on the right. The agent actually gets installed on premise, and we talk about that borrowing from Internet of Things concept. It's out on the edge, so it's not the Internet of Things. Usually the edge might be your car or your refrigerator or a toaster. This edge is really where your PLM systems are running. So the agent's installed there, and it communicates between your internal PLM systems and back to our cloud applications. If your PLM system was running in the cloud, the agent will be installed with those PLM systems in the cloud. We have so I think if you saw Stan's presentation earlier today, he was talking about a new thing that we've provided. And this is, instead of integrating directly with a PLM system, you might want to start somewhere else. For example, in AGCO's case, they weren't using the right part objects in Windchill, so they couldn't start using our Windchill integration. And they're using this file system integration capability. But you might also have a system that we don't support yet. You might have a homegrown system, or you're just not ready to start with PLM and would like to use CIG, but use it in a way that's not directly tied to your PDM or PLM system to start with. So it's analogous in some sense to how bulk costing works if you're running that from a command line. So what it does is, first, your costing inputs and CAD models are going to be stored in the file system. So when you set up a workflow, what you're going to see is a folder's created in your file system where you've installed the agent. When you do that, you describe where this directory will be. And for each workflow, you're going to see an inputs area. So you're going to have an input for a spreadsheet file, so one part per row, just like bulk costing. You can see the columns here are those. That's where you're going to set up your costing inputs. So like the process group, material, other things like that, VP that you want to use. And then there's an area for where you're going to place the CAD files. And then when a workflow runs, it can be run on a schedule, or on the new functionality that we're providing in our current release that we're working on and be at the end of this year, is the ability to start the workflow from an external application. So if you're automating this process, very similar to what AGCO is doing, you'll be able to kick off the process instead of having to run it on a schedule. So that application would sit there and look for things and work with the PLM, or in AGCO's case with the engineering team, to grab parts. When it's ready, it kicks off the workflow. It's going to set up the input sheet and the spreadsheet files. And then the output sheets or the outputs are written to also an Excel file. And if you're generating reports, there's a folder there as well. So you're going to have one of these, an output sheet that basically gives you cost information. You use the workflow to define what columns you want to put into that spreadsheet. And for each job that runs, you'll have a different folder area. So that's a new capability that we've added in 20.1 release. So when defining workflows, the first thing that you do is create sort of a name and a schedule for that workflow and when it will execute. And as I said, if you're going to start that from an external app, you can skip the schedule part of this. And then you create a query to extract the parts from the PLM system. So there's an expression builder here that allows you to look at things that, let's say, were checked in the last day. You might want to check for parts that are specific to a certain process group or commodity type, for example. If you're using the file system, you don't need to do this because the parts themselves are going to be in the input spreadsheet. But this is when we need direct integration with PLM. Next step is defining cost inputs and overrides. And this is a really important part because we're trying to get early results, but also accurate results. And you want to be able to fill in the right things. So you can pull attributes if you have those stored in the PLM system. You might be tagging parts that need to be costed, for example. You might be putting a process group in there, a material type. Those can be pulled and driven to the costing inputs. You can write things like, if the value is null in the PLM system, then default it to this value. So you can set up default and constant values here as well. We also take advantage of PMI attribute mapping. Ago was mentioning that they store material in some of their CAD files, so you can pull that information as well. That'll happen automatically if you use our PMI attribute mapping capabilities. And all the other defaults, VPE defaults, can be used. There is a special costing user for CIG that gets set up. You can define defaults for that costing user as well. And finally, you're going to configure the action. So this is where you set up whether a report's getting generated, whether you're going to set up an email. A question that came up earlier today about can you email more than one person? Yes, you can send emails to multiple people. The other point as well is we've developed a new report that instead of just sending a one PDF report per part, especially for emails, if cost engineer was going to get all of the results, for example, from this workflow, you wouldn't want to send them, let's say, 100 PDF files. So there's an option to group all the parts into a single report. We're also looking at things where instead of, you could put a filter on the email, so send only parts that have, let's say, a critical or a high DFM risk rating, as an example. So lots of enhancements in this area that we're putting into the system. So finally, in the last slide, just I think what's really important we're thinking about here is how do we, get early access to these DFM insights and support really cross-functional collaboration. So for the design engineer, we're pushing results back to them that help them avoid designs that are going to add cost down the road, but we don't want to put extra burden on that design engineer. So make it as easy as possible. And that was something AGCO was stressing, make that easier. Another is if you look at sort of a cost engineer, how can we scale that function? And this is a great way. It's very easy in Cost Insight Generate to develop a workflow that's going to push, let's say, tens or hundreds of parts to a single cost engineer, allow them to quickly look at what those results are. They could go into Cost Insight report, use one of our DTC reports, let's say on sheet metal parts, if that's what you're costing. They can look at outliers, they can remove parts from that collection. They can then, determine which parts really need to be focused on, go into Cost Insight through the links that we provide, assign those parts to design engineers. So it's really designed for a collaborative way of function. So with that, I'm going to turn it over to Mark. And Mark, I'll up to you.
All right, thank you so much, Pat. Great to hear about the automation that we have in place. So I'm going to talk about the metrics that we generate in the design to cost, design for manufacturability realm, and really where they're available and who they're valuable to, since obviously a lot of this automation is really dependent on getting valuable data that you can analyze and act on. So really everything that I'm going to talk about is driven by the design to cost and design for manufacturability metrics that we generate for the 6 different process groups that we support. So we support all these metrics in plastic molding, die casting, sand casting, stock and 2 model machining, as well as sheet metal. And when we talk about design to cost, we're really flagging 2 types of issues. One being issues where geometry on the part is going to be really hard to manufacture. So some good examples of that are on machine parts, sharp corners or obstructed surfaces where it's just going to be really hard to get a tool to make those features. Another example is undrafted features on a casting, where if you don't have draft, it's going to be really, really hard to pull that part out from the mold. The other class of issues that we flag are geometry that's driving cost. So something that the engineer has control over and isn't necessarily hard to make, but it's just going to be costly to make. So things like slide and lifters in plastic molding, sheet metal castings that have machined features because of some geometry properties or some tolerances that have been applied. And all told, across those different process groups that we support and those different issue types, we flag over 100 manufacturability metrics that are available in the areas that I'm going to talk about next and are driving what I'm talking about. So one of the recent developments that we've put out that allows you to quickly understand whether or not a part is really worth investing time in. As Stan was talking about earlier, a lot of engineers are responsible for hundreds and hundreds of parts and just want a quick understanding of if they should dive in deeper on this, is a DFM risk rating. So the DFM risk rating is available in Cost Insight Design, in Cost Insight Report, and in Cost Insight Generate. And at a basic level, it's a high-level classification of the risk rating of that part. So we've broken the risk rating down into 4 distinct categories: critical, high, medium, and low, which are pretty self-explanatory in terms of what they represent, their priority in terms of what you should look at. And so those meanings across all of our supported process groups really mean the same thing. A critical part in machining is really the same thing as a critical part as sheet metal. It's really a very high priority part for you to look at. And the way that we calculate this risk rating is based on really the prevalence of issues on the part. So, if you have the same issue count on 2 different parts, one part is huge, one part is small, the small is going to get a higher risk rating than the large part, which has a lot of features, because a higher percentage of that part has potential problems. So that gives you a really good way to, at a high level, understand, should I focus on this part or not? Another way to get a high level of understanding of where I should focus my time is by reporting on components and design to cost metrics. So we have design to cost metrics available in the Cost Insight Report as well as spreadsheet reports. They're really meant more for analysis, so you won't be able to report on individual features, but you will be able to get data like the count of sharp corner issues or the count of draft issues that you have on individual parts. And then we also put in some unique metrics that allow you to understand things like the density of issues on the part, or the ratio of slow machining operations driven by geometry like contouring to the overall cycle time of your part. So this is really, really powerful, having this available so you can report across a large data set and identify outliers within that data set. And in terms of what we have available, out of the box, there's over 10 purely focused on DTC reports available that work with any data set that's been costed with Design to Cost Enable. And then also ad hoc reports can also leverage these various metrics. And those reports can be built very, very quickly to allow you to focus on really what is most valuable to you for identifying those parts. And then once you identify the parts that you really want to spend your time on, really one of the most critical pieces of this design to cost functionality is the interactive guidance available in aPriori Professional or in Cost Insight Design, where you can visually see on your part where the issues lie. And we're also communicating data in a couple of different ways. First of all, we provide the rich context-sensitive help that we see on the right-hand side of the screen, where we describe what the problem is and a general ways to address the problem. And then we also provide detail issues on a feature-by-feature basis that allow you to understand what is the general threshold that we exceeded for this feature to cause the problem. So basically, what is the data? What change do we need to make to rectify this potential issue? Really giving engineers the information that they need to make the decision about, do I need to make this design change? Is it a feasible design change to make? And allow them to have that information available to go take action. I know that we're running a little bit low on time, so I'm going to skip over these last 2 slides pretty quickly, but just want to give you awareness that they are available in the PDF. First of all, configuration is possible for all of this design to cost metrics that we generate, both at a simple level, sort of adjusting thresholds, and at an advanced level, you can add additional metrics that your company wants to flag. And then lastly, and that is outlined in the user guide very robustly. And then lastly, just want to give you guys a very, very brief insight into what we're working on in the very near future for 2021 R1. Our biggest project is really sheet metal stamping DTC. I know that's been a very popular request. So we're focusing on really progressive die, stage tooling, and transfer die, and adding design to cost support for those routings in sheet metal. And then we're also doing some other work to improve our user interactions, continuing to enhance that risk rating that I talked about earlier. And as time permits, we're going to make improvements to existing process groups, like some focus enhancements to machining. Some of the learnings that we have from sheet metal stamping, we're going to roll into soft tooled sheet metal. And this is an area that we're going to be continuing to invest in for the foreseeable future. It's really powerful area for you guys, and we're committing a lot of effort to enhance this and make it as useful as possible for all of you to take advantage of. And with that, I want to pass it back over to Tobias to wrap things up.
Yes, so thank you very much, everybody, for attending this session. To really quickly close the loop, since we're already over time, I would like to encourage you to go back to, if you haven't had the chance, 2 sessions that have been earlier today as addendum to the topic, which was the case study by Stan Kröker, ACO, expanding aPriori from manufacturing engineering into design engineering and driving to the best engineering decisions, that were just before that by Amanda Bly of aPriori. Also, we would appreciate if you could rate the session under the survey link at the bottom of the conference page, and then we wish you a great rest of the conference. Unfortunately, there's no time for Q&A, so feel free to write us through the conference platform or an email, and we are happy to respond. Thanks, everybody.